So what I'm going to do is I'm going to show you this. Let's see. For when I use this program, my recorder doesn't show up, my timer doesn't show up. So let's say about 7 after 1, I need to be done. So make sure I don't go past that. Okay. All right. So here we go. So it gives you all these chapters. We're on chapter 1. We're now on 1.7. So all right. So here it is. So it gives you all these menus you can go to. We are going to go to this right here. Actually, I lied. Let's go to this right here instead. It's not spazzing out. What do you mean it's spazzing out?
The little thing. The arrow.
What was it? I don't know. It's fine now. Okay, let's pay attention. Here we go. Here's some things you should write down. First of all, a polyhedron. What in the world is a polyhedron? But basically, it's in the book. I don't have the book in front of me, but it's page 60. Anybody got their book open? Look, section 1.7. Where does section 1.7 start? Like at 67 or something like that, or? Okay, and you should see a definition for polyhedron on there, don't you? Yeah, polyhedron. Read it for me, David. What does a polyhedron say it is?
A solid with a flat surface.
Okay, stop right there. A solid, which means it's a three-dimensional object. It's not just a flat surface. Okay, when they talk about a solid, they're talking about a three-dimensional thing, not just flat. Okay, so it says a solid with what? Flat. With all flat surfaces. Okay, so they all have to be flat surfaces. Nothing curved. All right, it's got to be completely flat. You got it? So a polyhedron. So every surface on here. Do you see that? See the top of this? It's flat. See the bottom? It's flat. Everybody see it? All the sides are what? They're flat. Okay. What else does it say?
That it encloses a single region of space.
Okay, that it encloses a single region of space, which basically means there's no open areas to it. It's not like you got a lid and it's open up. Okay, it's all closed up. All right, and all the surfaces are what? What did I say? Flat. That's right. All the surfaces are flat. That is a what? Polyhedron. Okay, polyhedron. That's what they call that thing. Well, there's two main types of polyhedrons we're going to talk about. First one is what? Prism. Okay, so what is a prism basically? Well, it's a polyhedron. Now, these are polyhedrons. These, guess what, are not polyhedron. Very good. So let's talk about the polyhedrons right now. So a prism, what is it? It's a polyhedron with two parallel congruent faces. What does that mean? Parallel, right? You know what parallel means. We talked about parallel not too long ago. All right. I think we talked about, did we talk about that? Or maybe it was the other class I talked about parallel. Well, anyway, two parallel congruent faces. Congruent means they're exactly the same, which means, look, the bottom of this and the top of this are exactly the same. Make sense? And what do we call those two congruent faces? We call them bases. That's right. Okay, they're bases connected by parallelogram faces. All right, don't worry too much about that. But all these different sides could be considered a face of this prism. The top could be considered a face. The bottom could be considered a face. Okay, the sides, each of those sides could be considered faces, all right, of this polyhedron. Now, the top and the bottom, the ones that are both exactly the same, the top and the bottom are called bases. And that's what we're going to concern ourselves with quite a bit. All right, we good so far? Prism. So what's a prism? Flat surfaces, right? The top and the bottom are exactly the same. Everybody got that? So the top and the bottom of a prism are exactly the same. We give that a name. We call them what? Bases. All right. What's the difference between a prism and a pyramid? Look at it. A pyramid has a base, but what's it do? It all comes up. All the sides come up to a what? To a point, which is called the vertex. Okay, so the point is called the vertex. So a pyramid all comes up to a point. What do all the sides do here? They all go straight up, don't they, into another flat surface. So on a prism, all the sides come up to a flat surface. On a pyramid, all the sides slant up to what? One point called the vertex. How many bases does a pyramid have? Just one. All right, just the thing that it's sitting on, that's the base of the pyramid. Okay, the point where it comes up to is called the vertex. Now, this also has faces. See this triangle right here up front? You see it? That's a face of the pyramid. This triangle right here is a face. There's a triangle in the back of it. Do you see it? See, from here to here to here. All right, that's a face. And then you got this side. It's not quite so easy to see, but you can imagine that left side over there. That would be a face as well. So you got faces, you got a base. Oh, by the way, what about the line segments themselves? We call these things edges. All right, so from here to here is an edge. From here to here is an edge. There to there. You get it? So each of those line segments that are formed, right, by those faces are called an edge. And now this has a vertex on the top, but this has a bunch of vertices, right? Vertices is a plural for vertex. It has a bunch of vertices too. Wherever it comes to a point, any place it comes to a point is called a vertex. Everybody got that? All right. This one right here, when all the sides come to that one common point, that's the vertex as well. You got it? See? It says it's a polygonal base. Polygonal comes from the word what? We talked about this the other day. What do you think polygonal comes from? Polygon, that's right. So the base is a polygon, right? Whatever shape it is. In this case, it happens to be a four-sided figure, okay? And it all comes to a point. The faces are triangles, meet at a common point, a vertex. Okay, good enough. That's a polyhedron. Two types, a prism and a pyramid. Now we're going to do some stuff a little bit later with a prism and a pyramid, all right? What about this right here? These are not polyhedrons. Why in the world is that not a polyhedron and this is? Look, it's got a flat surface on the top and the bottom, doesn't it? But what? It's a curved surface. That's right. You got a curved surface. Do you see that? Oops. I accidentally clicked. Didn't mean to do that. All right. Look, it's curved. It's not just all flat surfaces. Look at this thing on the side. Okay. Think of a Coke can or Pepsi can or something like that. Okay. The part that you hold on to, right, is curved, isn't it? It's not just a flat surface. So what did we say a polyhedron has to be? Flat surface. Okay. So if it's got any curve to it at all, then it's not a polyhedron. That's why these are not polyhedrons. Look at this thing right here. That's curved, isn't it? This thing right here, that's curved. They're not all flat surfaces. So these are not polyhedrons. But we do still get names for them. This one right here, it's kind of like a prism. Look, it's got two bases. It's got a flat surface on top. It's got the same exact type of surface on the bottom, right? Congruent and everything else. Except it's curved. It's a circle. Okay, it's not a polygon as a base. Okay, all these polyhedrons must be a polygon for a base. This one right here, it's not. It's a circle. Everybody got that? Okay, so we call this a cylinder. All right, you've seen tons of cylinders like that. A lot of cans. Pringles cans is a great example of a cylinder, isn't it? All right. What about this? A cone, ice cream cone. Okay, turn it upside down, right? You got a nice ice cream cone, stick some ice cream in there. What do we do though? We call this circle that it's sitting on, we call that the base. And then it comes to a point. So a cone is very similar to what type of polyhedron? It's similar to a pyramid, isn't it? Except the sides aren't flat surfaces, are they? Okay, it's curved, but it still does come to a point. A cylinder is similar to a prism. All right, similar to it. It's not the same thing, but it's kind of like a prism, except you got a rounded surface to it. All right, what's a sphere? A sphere is basically just a ball, isn't it? Look, if I have one point, we'll call that the center, and I go out the same distance in all directions. So if I had a point right here, and I went the same distance out in every single direction I could from that point, guess what I would form? I would form a sphere or a ball, okay? And we just call that a sphere. It's kind of a weird word, isn't it? Sphere. You know any other words that S and PH sound don't go together too much in our language, does it? All right. Sheep? I don't think so. I don't think that's the same deal. But there you go. Look what a sphere. It has no faces, right? Because there's no flat surfaces. It's all round. It's got no edges and it's got no vertices. All right? There we go. Make sense? You need to be able to know what figure is what. And that's in the worksheet I'm going to give you today. The first set of problems, they're going to ask you to tell that. They're going to say, what kind of figure is it? You're going to have to tell, is it a polyhedron or is it not a polyhedron? If it is, which kind is it? Is it a prism or is it a pyramid? Right? If it's not a polyhedron, is it a cylinder? Is it a cone? Is it a sphere? And you're going to have to be able to tell that. You also have to be able to tell which one are the bases, which one are the faces, which one are the edges. You with me? So what kind of a thing is an edge? Is an edge a plane? Is it it's a line segment? What about a face? A face would be a what? Would be a plane, wouldn't it? It'd basically be a plane. So if this was labeled A, B, C, D, then this would be plane A, B, C, D. You follow me? All right, and same thing with this. A vertex is always a point. You get the idea. Everybody good with that? Yeah, that's pretty easy. All right, let's move on. Let's look at this example. It says determine whether the solid is a polyhedron. Is it a polyhedron? Yeah, all flat surfaces, right? It's the same on the top and the bottom. So yeah, it's a polyhedron. Identify it. Which kind? Now we had two types of polyhedrons. Which kind is this? This is a prism. That's right. It's a prism. So if it's a polyhedron, name the bases. Which ones are the bases? Well, the top and the what? The bottom. What would I call the top? Let's start at E. E, F, H, G. What about the bottom? C. Which way do you want to go? A, B, D. It doesn't really matter, right, which direction you go. You can't do this, though. You can't say C, B, D, A. You with me? All right. If I start at C, I either have to go to the A or I could do what? Go to the D. All right. So those are my two what? Bases. What about my faces? The F, A, C, E, S. So which one would you say? G what? G, H, C, D, C. Yeah, that would be a face right there. There's a bunch of them. Right? There'd be the front one. There'd be the what? The right one. There'd be the back one. There'd be the left one. You could still say the top and the bottom, couldn't you? That could still be considered a face.
You can spell face and edge.
Oh, look at that. Isn't that amazing? All right, what about the vertices? Oh, let's do the edges. I forgot. What about the edges? E what? EF? E what? What's another one with E in it? E what? EA. That's right. Those are all your edges with E in it. What about F? Well, you already said FE, didn't you, when you did EF? So FB and FH. You get it? So you could keep doing all those segments, couldn't you? You with me? So that would be all the edges. Okay, not hard to see. There's a bunch of them, so you got to write down a whole bunch of them. What about the vertices? What would be the vertices? Just be all the what? All the points. That's right. It's just all the points where all those line segments come together. All right? Watch. We call it a polyhedron, right? The bases are rectangles. The solid is a rectangular prism. Now, here's all the bases. I'm not going to go through all those again, but we talked about them already, right? There's your bases, your two, right? Your the top and the bottom one. Faces are all the all the different sides. Your edges, right? We talked about the line segments. Vertices are all the points. Everybody got that? Pretty easy. All right. What about this? Now look, this one is a little different. This one's kind of sitting on its side, isn't it? So if I talk about the bases, I'm not really talking about the bottom right here. What do you think the base would be to this? Yeah, KLMNOP. Okay, that's what one base would be. What would the other base be? EFGHIJ. Right. Those would be the two bases, even though it's not sitting on them, right? I could take that. What do we call this, by the way? What kind of a solid is this? It's a... Well, is it a prism or is it a pyramid? It's a prism, okay? How many sides are there? There's 6. So we wouldn't call it a hexagon prism. We would call it a hexagonal. Does that sound crazy? Hexagonal prism, all right? What if there was 5 sides? What would you call it? Pentagonal is how we would say it. Pentagonal prism, okay? So it's a prism, but it's sitting on its side. If we put it up straight up and down, you could see what the bases are, couldn't you? See, there's one base right here. Here's another base right here. And you know what the faces and edges and vertices and all that kind of good stuff, all right? Let's go through that. See, bases are hexagons, so we call it a hexagonal. Everybody see that? Oops, right there. Hexagonal, right there, prism. And there's all the stuff. We talked about that enough, don't you think? Yeah. Let's keep going. Ooh, what about that thing? What's that thing? Yeah, first of all, is it a polyhedron? No, it's not. Okay, identify the solid. You just said it. What is it? It's a cone. Okay. It says if it's a polyhedron. Well, guess what? It's not a polyhedron. So do I have to name the bases, faces, edges, or vertices? No. Okay. It does have one vertex, though. What is it? How about W? Okay. Say it's a cone. All right. It does have a vertex, W. It has no faces or edges, and the base is a circle. Okay? All right. You with me? Let's skip all this. Yeah, you're right. Let me. I'm gonna probably have to stop this. Hopefully I didn't go past 15. I hope. Let's get through this quick. Exit. Alright, then put this on. Oh, boom.